All right, yesterday we talked about finding combinations and we were calculating these by hand. So again, this is read as 8, choose 3, and you can think about it as you have 8 things. How many ways can you choose 3 of them? Remember, for these, order does not matter. So a good example of these is when we talk about decks of cards, because when you pull a hand from a deck of cards, obviously you can reshuffle it once it's in your hand, so the order does not matter. So that's what example 2 uses. We're going to find combinations here. So example 2, it says a standard deck of 52 playing cards has 4 suits with 13 different cards in each suit. If the order in which the cards are dealt is not important, how many different 5-card hands are possible? So we have this nice little thing here in case you need to count for any of these problems. But basically what this is we have 52 cards, so 52 choices. Choose 5 of those. So it's 52, choose 5. And that's because we have a deck of 52. And our hand that we're drawing is 5. So if we were to calculate this by hand, using that formula yesterday, it would be 52 factorial over 5 factorial times 52 minus 5 factorial. It turns out, as with many of the things we do in this class, your calculator can actually do this for you. So I'm going to show you today how to do this in your calculator. So on your calculator, get all this out. So recall you have a math menu, right? I can turn on my little pointer here. So you have your math menu. Oops, I just drew them in instead. There we go. Math menu is right there. And notice you should have some options. So I got to move my screen down, but you should have some options along the top. And one of them says PRB. That stands for probability. So scroll over to the PRB one. Let me pull this down so you can see that. So PRB, and this one has extra ones, but it should be, I think, the last option if you're using your physical calculator. Again, that stands for probability. And then if you look, this third option here, this is our N choose R. So if you scroll down to N choose R, 2 things are going to happen. If you have an older calculator, what just popped up should have been ANS for your previous answer, C, and then a blank. For your older calculators, you need to type in, before you go into the math menu, you actually have to type in the number first. So you'd type in 52, then you hit the math menu, you scroll over to the probability, go down to your third choice, hit enter, and then it'll take that 52 as your N. And then your choose, we said, was 5, and you can just hit enter, and you should get 2,598,960. If you got something different, let me know. Again, if you have an older calculator, what you need to do is you type in 52 first, then you hit math, scroll over to probability, scroll down to number 3, and it should just, it'll look like it's all on the same level. It'll look like this. Again, this is a newer calculator app, so it doesn't quite look the same, but if you have an older one, it's all on like the same level like this, and you just hit enter and it should give you the answer. If you have a newer calculator where it actually gives you like the subscript, then you don't have to worry about that. So we know the answer now is 2,598,960, which is pretty incredible. There's 2,598,960 different 5-card hands in a 52-card deck. So part B, this one's a little more complicated, and we will talk about this more tomorrow, but I just want to kind of practice how to type this into our calculator. So it's asking, in how many 5-card hands are all 5 cards of the same color? So for all 5 cards to be the same color, you need 1 of the 2 colors, and then 5 of the 26 cards in that color. Okay, so you need... so for all 5 cards to be one color, you need to choose one of two colors. So let's write that first of all as a choice, a choose equation. That would be 2, choose 1. You have 2 color choices. You're going to choose one of those. Then you need 5 of the 26, and that's half the deck, because half of the deck is one color. So 5 of the 26 cards in your hand. So what would that equation look like? That one would be 26 options, 26 cards, choose 5. So how do you put these together? And again, we'll talk about this tomorrow, but how you're going to put these together is actually multiplication. This is an and. So this is going to be 2, choose 1 times 26, choose 5. That 2, choose 1 is you have 2 color choices, choose 1 color. 26, choose 5 is you have 26 cards in your hand, choose 5 of those now. So how you type this into your calculator, I'm guessing that parentheses will matter here, and I say guessing because I haven't played around with it too much, and everybody's calculator might be a little different. So to be safe, let's use our parentheses. So you should put parentheses. If you have an older calculator, you should type in the 2 right now. If you have a newer calculator that actually does the subscript, you can go to math, go over to probability, choice 3, and we need 2, choose 1, and then, whoops, scroll over to get out of the subscript if you have to do that, and then hit your parenthesis, times another parenthesis, and then again, same thing if you have an older calculator. At this point, you should type in 26, and then do your math choose. If you have the newer calculator, go over to math, probability, option 3, we have 26, choose 5. Hit enter, and you should get 131,560 different hands. So our final answer here is 131,560 hands. So if you have only, so basically how many 5-card hands of all 5 of the same color, this would be 131,560. So if you're thinking in terms of poker, there's 131,560 different ways to get a flush.